Welcome to Learn AI with Brema. Let's get right into it. Have you ever asked an AI a question and gotten an answer that was confidently but just completely wrong? Yeah, it's a huge problem. Today, we're going to break down exactly why that happens and, more importantly, how we can fix it.
It's the big question on everyone's mind, right? How can these systems that seem so incredibly intelligent just make things up? This whole phenomenon, what we call hallucination, is a major roadblock, especially for businesses that need AI they can actually rely on.
And you know, the problem goes way deeper than just some made-up facts. The AIs we have today, even the most powerful ones, often have no real long-term memory and can totally struggle with basic logical reasoning. And here's the crucial part. When they give you an answer, it's pretty much impossible to trace how they got there. For any business that needs reliable, audible results, these aren't just little quirks, they're absolute deal breakers.
So how in the world do we fix this? Well, the solution starts with building a better brain for our AI. And the first key component of that new brain is something called a knowledge graph.
Okay, so what is a knowledge graph? The easiest way to think about it is like the AI's long-term memory, or its own personal fact-checked Wikipedia. It doesn't just store random bits of information, it actually stores the relationships between them. So it knows that Tesla was founded by Elon Musk, and that Elon Musk is a person. It's this beautiful web of verified facts.
Now this is where it gets really interesting. An LLM on its own, it's like a brilliant, super creative linguist who, sometimes improvises to fill in the gaps. But when you connect that linguist to a knowledge graph, they now have a meticulous reference library to work from. It can't just invent facts anymore because it's grounded by them. It understands context because it can literally see the relationships.
Okay, so you might be thinking, hold on, isn't this just a super fancy database? And that's a fair question, but this really shows why it's not. A traditional database is rigid, built for storing transactions in neat tables and rows. A knowledge graph is flexible, designed to map out how concepts actually connect in the real world. So here's the bottom line. A database is for storing data, a knowledge graph is for storing knowledge and making sense of it.
That knowledge graph, it gives us the factual foundation, right? But believe it or not, that's only half the story. To create a truly intelligent system, we need to combine this logical brain with the creative power of neural networks. And this incredible combination has a name: Neuro-Symbolic AI.
Neuro-Symbolic AI is pretty much exactly what it sounds like. It's the fusion of the neural world, things like LLMs that learn from massive amounts of data, and the symbolic world of hard logic, rules, and facts, which is right where our knowledge graph lives. It's truly the best of both worlds.
I absolutely love this analogy because it just clicks. You've got your neural network. That's the creative linguist. It's amazing at understanding the nuances of your question and spotting patterns. But its partner, the symbolic system, that's our knowledge graph and rule engine, is the meticulous fact checker. It's the one making sure every statement is true, every rule is followed, and every single answer is grounded in cold, hard reality.
So how does this dream team actually work together in practice? It's a really simple but super powerful workflow. Let's walk through it. First, the neural model reads your question and pulls out the key concepts. Step 2, it uses those concepts to go find verified facts and relationships from the knowledge graph. Then, and this is key, a symbolic reasoner acts as a filter, making sure the information is accurate and follows any rules. And only then, in that final step, does the LLM take all this grounded, verified info and craft a trustworthy answer you can actually use.
All right, so this isn't just some theory cooked up in a lab. This hybrid approach is already out there, powering some of the most advanced systems we use every single day. Let's look at a few quick examples.
First up, Google. You know those little info boxes that pop up at the top of a search? That's not just an LLM guessing. That's Google's massive knowledge graph feeding it structured, verified facts to make sure the answer you get is reliable. Or think about something like autonomous driving, where the stakes are incredibly high. A neural network might be great at identifying a pedestrian, but it's a symbolic rule system that enforces the non-negotiable logic. If you see a pedestrian, then you hit the brakes. You absolutely need both perception and hard-coded rules for safety.
In healthcare, this is a total game changer. An AI can read a doctor's notes, for sure, but a medical knowledge graph ensures it understands the complex relationships between diseases, symptoms, and treatments. And that leads to way safer and more accurate clinical support.
And then there's the world of finance, which is just built on a mountain of complex regulations. A neurosymbolic system can understand what a customer wants and then instantly check it against a knowledge graph of compliance rules to make sure every single action is legal and auditable.
And this brings us right back to where we started. A lot of companies are building chatbots using a technique called Retrieval Augmented Generation, or RAG. By grounding this process with a knowledge graph, they can build systems that retrieve verified facts, not just random snippets from a document. This, right here, is the key to finally solving the hallucination problem for good.
So, after all that, what's the big takeaway? What does this all mean? Well, we're looking at a fundamental shift in how we build intelligent systems, especially when it comes to the enterprise.
This quote just says it all, doesn't it? The fusion of the learning power of LLMs with the logical rigor of symbolic reasoning, it's not just some new feature. This is the future of enterprise AI.
And what does that future actually look like? Well, it's AI that is finally accurate and robust. It's explainable, which means you can ask it why it made a decision and actually get a real traceable answer. And it's controllable and compliant, things that are absolutely essential for any serious business. So I'll leave you with this one final question. As you think about using AI in your own world, the most important thing to consider is trust. How will you make sure the systems you build are reliable, factual, and safe? The answer, as we've seen, lies in this powerful hybrid approach.
Look, the world of AI is moving at lightning speed. Understanding these core, foundational concepts is what's going to set you apart. And that's our whole goal here at Learn AI with Brema, to help you understand the future so you can stay ahead of the curve. Thanks for tuning in.